Welcome to Colorado State University's podcast, The Audit, where host Stacy Nick talks with CSU faculty about topics ranging from their latest research to current events.
For the past 40 years, Colorado State University has been at the eye of a hurricane, or at least the eye of hurricane forecasting. Despite its landlocked location, CSU is well known all along the Atlantic coast for its seasonal hurricane forecasts. Each spring, these forecasts predict the total amount and potential strength of storms for the upcoming hurricane season. The forecasts were first developed and shared by pioneering atmospheric science researcher William Gray, and are frequently used by media, officials, and community leaders to inform the public and make planning decisions. Today, Gray's former grad student, Phil Klotzbach, leads the effort to inform communities up and down the East Coast of the dangers the upcoming season presents. Klotzbach is a senior research scientist for the Department of Atmospheric Science within the Walter Scott Jr. College of Engineering, and along with a team of students, faculty, and research staff, has authored the forecasts since 2006. Today, I'm talking with Klotzbach about CSU's role in developing hurricane research, the increase in hurricane activity and destructiveness over the years, and what we can expect in terms of size and scale for future hurricane seasons. Well, let's start with what led you personally into this field of research.
I've been fascinated with the weather since I was a little kid. I grew up in Massachusetts, in Plymouth, so right along the water. And so when I was 5 years old in 1985, we had Hurricane Gloria come through. It came through Connecticut, but brought some pretty significant impacts even into southeastern Massachusetts. And then when I was 11 years old, Hurricane Bob came through, and that brought a lot more significant impacts. We had a lot of trees down. Tree came down very close to our house with that storm. So that really got me especially fascinated with hurricanes, but I've been really interested in the weather for as long as I can remember. But right now it's all about trying to figure out what makes hurricanes tick.
So what makes hurricanes tick?
Well, the group that I work with, Michael Bell's group, we study hurricanes on all sorts of timescales. So what I lead is the seasonal Atlantic hurricane forecasts, which were pioneered by Dr. Bill Gray all the way back in 1984. So this is our 41st year of doing seasonal hurricane predictions. And it's pretty interesting. So, I was an undergraduate in Massachusetts studying geography, and I took a climatology class, and I was interested in hurricanes. And so the professor of the class was like, oh, there's this guy in Colorado who forecasts hurricanes on a seasonal timescale. I was like, that guy's nuts. There's no way you can do that. And I read up what he was doing. I was like, hey, he actually knows what the heck he's doing. So I've been trying to follow in his footsteps and continue the seasonal hurricane predictions ever since.
It's interesting. I think that there's a general sense of when people first hear that the top hurricane research is coming from Colorado. How did CSU come to be the epicenter of this type of research despite being landlocked?
Yeah, so Dr. Gray, when people would ask him why forecast hurricanes from Colorado, he'd say it's because the storm surge can't get you at 5,000 feet. But no, in all seriousness, basically the guy who started the department was a guy named Herbert Reel. And Herbert Reel was asked to start the department. He was coming from the University of Chicago, which is still nowhere near hurricanes, but he was a big hurricane researcher at the University of Chicago. So he started the department. Dr. Gray was finishing off his PhD at the time. So he finished off his PhD and followed soon after Herbert to Colorado State University. After Dr. Gray passed, he found the offer letter from Herbert Reel to Bill Gray in his office. The original signed letter was still there. So Bill Gray was one of the first guys in the department. So our department does all sorts of different research, but we've always had one or two faculty members really focused on hurricane research, either predictions, modeling, all of that good stuff.
Does it ever feel weird for you guys, or does it just feel like, yeah, of course we're at CSU. Of course this is happening here.
There's a lot of hurricane research done really up and down the Front Range of Colorado State. And there's a lot of research, obviously, at NCAR in Boulder, as well as some at CU Boulder as well. So there's a surprising number of hurricane people along the Front Range of Colorado. So far removed from hurricanes, but I do a lot of conferences, which take me to places like Florida and Texas. So I've certainly been in a lot of very hurricane-prone areas every year.
How has the team kind of evolved since you've been there?
So when I started at CSU, so Dr. Gray he formally retired a couple years after I started, but I worked closely with him. He was working as an emeritus professor. So he and I worked very closely on the forecasts until his passing in 2016. And then basically right about the same time Dr. Gray passed away, Michael Bell joined our department as a professor. He also went to CSU for his master's, so I knew him from back a lot further, back in the early 2000s, but he came to CSU as a professor in 2016. So after Dr. Gray passed, I started working with Michael, and so now there's several of us from Michael's group that work on the seasonal hurricane forecasts.
Now, for people who maybe don't know much about the hurricane forecast, can you give me kind of a quick basic explanation of how the forecast is done and how accurate it is? And I mean, I know you guys start doing these forecasts, I think it's in April, and then you do updates later, but that's pretty early to be calling what's going to happen in August.
Yeah, so we have been doing seasonal hurricane forecasts since 1984, and a lot of this goes back to that Bill Gray discovered a relationship in the early 1980s where when you have El Nino conditions in the tropical Pacific Ocean, you get fewer hurricanes in the Atlantic. And so it's like, why on earth would something going on in the Pacific impact hurricanes in the Atlantic? And so basically he discovered that when you have warmer than normal water in the central and eastern tropical Pacific, which is what you have when you have El Nino, it shifts where the Pacific thunderstorms form a bit farther to the east. And because of that, you get increased winds up out of the west that increases basically what's known as vertical wind shear, which is the change in wind speed and direction with height in the atmosphere. Too much shearing tears apart the hurricane. So when you have El Nino years, you tend to have more shear, fewer hurricanes. La Nina years, less shear, more hurricanes. So this is kind of one of the first relationships he discovered because you can predict El Nino usually several months into the future. So that gives you some seasonal predictability of Atlantic hurricane activity. So it was the discovery of that relationship that really got him kind of motivated to start doing these seasonal predictions. But now he has a whole pile of different predictors. And those predictors have somewhat changed with time because the climate is not stationary. So we're always basically looking for ways to improve our seasonal forecasts. And certainly I'd say we've come a long way since the original methodology that Dr. Gray pioneered in the early 1980s, thanks to a lot more sophisticated computer modeling than we had 40 years ago.
This season is forecasted to be one of the busiest on record. I think you had like 23 named storms and including 11 hurricanes. It's kind of crazy.
Yes, it is forecast to be a very busy season, and I can tell you there's a ton of interest in this hurricane season. I believe in April there were like 6,000 media stories on the seasonal forecast from CSU. Just we're recording the podcast today. I've done 3-hour-long webinars on the hurricane season already today. So there's a lot of interest in this hurricane season because it is forecast to be so active. So the primary reasons being that we had El Nino last year. It's weakening very quickly, likely to transition over to La Nina, which is colder water in the central and eastern tropical Pacific. That tends to reduce your shear, so making the winds more conducive for hurricane formation. And the Atlantic right now is record warm. So we have what we call the main development region, which is the main region where hurricanes develop, is running at record warm levels. So that provides basically more fuel for the storms. It also tends to be associated with a more unstable atmosphere and more lower pressures, all of these things that you want if you're looking for a busy hurricane season. So with the forecast from our group, from NOAA, from all these different groups for calling for such an aggressive hurricane season, certainly there is a lot of interest. And I can tell you, I started doing interviews on this hurricane season back in January, just because the Atlantic was so hot. People were already starting to talk about the season in the dead of winter. And normally in January, I don't do very many interviews. So there's been a lot of interest in this season for a while now. And so, anticipation is growing as we officially in the hurricane season, and this stuff is now starting to kind of pop up that may start being something that we may actually be causing impacts.
After doing this for so long, where do you see the trends going? Because I feel like, while I'm wishing that your answer would be we're going to see fewer and less destructive storms, I feel like that's not the direction things are going.
Yeah, so there's, we published some papers looking at this a few years ago. And so, there's big increasing trends in damage from hurricanes going back to 1900 or whatever. Most of that increase in damage is just effectively more people and more stuff along the coastline. So as people move to the coast, you have more people there. You basically increase the exposure to these catastrophic weather events. So there's that piece that's been a big driver of the increase in damage to date. Of course, we could always delve into the realm of climate change and how it may be impacting hurricanes. I mean, certainly with just the sea level rising, that means when you have that storm surge, so that wind-driven increase in water level that you get with hurricanes, that storm surge is going to go penetrate farther inland because the sea level is higher. We also know that with a warmer atmosphere, we get more rainfall because the warmer atmosphere can just hold more moisture. So consequently, that also, it can increase the damage from storms. There's a lot of discussion, a lot of debate as to what other characteristics of hurricanes are changing. Now, that would probably be a topic for like a 6-hour podcast with all the different questions we could go on there. But, in general, the answer is probably not more storms, maybe even fewer storms, but potentially the storms that we do get will be a bit stronger. It gets pretty complicated because with climate change, you warm the surface, which warming the ocean provides more fuel for the storm, but you also warm throughout the atmosphere, and higher up in the atmosphere, you warm even more, and that tends to stabilize the atmosphere a bit. So that tends to counteract some of what you would expect, but overall, we do think that the warmer atmosphere will likely lead to slightly stronger intensities, as well as probably more volatile storms, so storms intensifying faster and weakening faster than they currently do.
Are the warm ocean temperatures that contribute to those larger storms that we're seeing this year and last year, is this the new normal for us? And if so, is that related to climate change?
We actually had a very pronounced change happen in about March of last year. So if we had done this podcast in February of 2023 and you talked about the Atlantic, I'd say, hey, the water temperatures are pretty much dead on average, not much going on. But in March of last year, basically the subtropical high pressure, so the Azores high and the Bermuda high, got very, very weak. And why the heck do we care about that? Well, when the pressures there fell, you basically, the winds that blow across the tropical Atlantic, which we call the trade winds that blow from east to west, those winds got a lot weaker because you weakened your pressure gradient between the subtropics and the tropics. And why that matters is weaker winds blowing across an ocean surface cause less evaporation. Kind of like you get out of a swimming pool on a windy day. It cools very, very quickly. But if you get out of a swimming pool and it's calm, you don't get cold as fast. So when you have less evaporation, that allowed the waters to warm extremely quickly from March to about June, and they've just stayed elevated since then. So in the answer to your question, I would say overall weather events are what made the Atlantic as hot as it is over the last basically year or so, but climate change kind of loads the dice towards these kind of events. There's still some uncertainties to exactly why it hasn't gone back at all, like why those hot temperatures basically persist. I mean, they obviously cool off in the winter, but relative to normal, they stayed well elevated. And there's some question about that. Some of it may be due to the circulation that we normally get with El Nino, normally, which we had last winter, typically reduces the strength of your subtropical high. So basically the subtropical high was weak because of whatever, and then it remained weak because of the El Nino, and now it's just so dang hot. When it's really, really hot, that tends to force lower pressure. So unfortunately, it's really getting too late for this hurricane season to see much, if anything, other than the warmest or the second warmest Atlantic on record.
With this kind of research, the historical records for hurricanes is not extremely complete because it's not like pulling an ice core or carbon dating will tell you what category a storm was when it landed in Florida in 1712. So there's still a lot of guesswork, I guess, in comparison of seasons and predictions of how storms will move. And I'm wondering, what does that tell you about the need for this field of research and also for future advancements?
So when we talk about seasonal hurricane prediction, our predictions generally we use basically build it on historical data going back to the late 1970s. And the reason we start then is because that's when we have pretty good satellite coverage globally. So we have a pretty decent idea of what the atmosphere was doing. And we have a pretty good idea of what the hurricane seasons were doing. Now you can go back further. I mean, Dr. Gray started this in the 80s. He went back to 1950. He would always call us kind of being snobby with using just the newer data. But as you go back in time, there's more uncertainty in both the hurricane data as well as in what the atmosphere ocean was doing. There's big gaps. If you go even further back, there's big gaps in World War II and World War I. A lot fewer observations during that time. It seems like even the late 1800s may be more reliable than World War I and World War II, just given the lack of observations during those two world wars. So one of the battles that we're kind of always fighting is, do you build your models on the more recent data where you're pretty confident, but you only have 40, 45 years of data? Or do you go back further and build it on a lot more realizations of the atmosphere ocean, realizing that there's going to be higher uncertainty in that? So, it kind of depends on exactly what you're trying to do. But with seasonal forecasting, again, we typically go back about 40 to 45 years. And unfortunately, like you mentioned, we don't have 10,000, 50,000 years of data, which kind of precludes a lot of these artificial intelligence techniques that are employed in a lot of areas of meteorology. When you only have 40 to 45 data points, you don't really need artificial intelligence to tell you what you should be using to predict storms. It's a lot more useful on, say, day-to-day weather prediction or on subseasonal climate prediction, say 1 to 2 weeks, where you have a ton more realizations. Then those artificial intelligence techniques become a lot more helpful. But on a seasonal time scale, when you only have 40 to 45 years, there's not that much you can't do by just like looking at maps and picking it out from that.
Where do you see CSU's hurricane research going in the future?
Our group does a ton of research on all different sides of things. So like one of my focuses is on the seasonal hurricane predictions, but our group studies everything from what's going to happen with hurricanes from, the next 5-10 minutes to what's going to happen, 100 years from now. So certainly from the seasonal hurricane prediction side of things, what we're trying to do is kind of historically what we've done is always basically predict the Atlantic looks busy or quiet. But what we're trying to do is get more regionally specific. So you can't say, June 13th, there's going to be a hurricane hitting, Brownsville on August 9th. Like, we're never going to have that kind of skill. But trying to kind of get more regional with, specific regions that might be impacted by storms, especially so fairly broadly, but at least kind of getting a little more towards what might be impacting. So we also do kind of like a tiered approach to forecast. So we do April is our first forecast. We updated in June, July, and August. And starting in August, we issue forecasts every 2 weeks. And those 2 week forecasts are just for activity during a 2 week period. And the reason why we do a 2 week period is because you can have a very busy time during a quiet season or a quiet time during a busy season. But also, then you can start to go from, hey, the Atlantic looks busy to, hey, let's look at specific regions that may be impacted by storms in the next week, 2 weeks. So last year, for example, August 18th, we put out a 2 week forecast and said, the Atlantic looks very busy. The central and eastern Atlantic looks quite busy. Most of the storms are probably just going to go out in the ocean and not be much of a threat. But there does appear to be something going to form late August, maybe Northwest Caribbean, Southern Gulf of Mexico. That's the system that you want to be watching. And that turned out to be Hurricane Idalia, which was the one major hurricane that hit the U.S. last year. So that's certainly not something we could say, 2 months in advance. But when you start to get more towards that 2 week time frame, then you can start to kind of hone in on areas that may be of significance. So that's kind of the cascade of forecasts that we issue. And then at the end of every year, we also do an extensive verification where we write up the season, describe what the forecast worked well, did they work poorly, and then talk about maybe some ideas of what we might do the following year to improve the forecast.
And you have an update coming out soon, right?
We'll update it again on the 9th of July and a final update on the 6th of August. And oftentimes people say, hey, you're cheating. You can't do this forecast. It's 2 months into the hurricane season. But about 95% of your major hurricane activity, which are your category 3, 4, and 5 hurricanes, occur after the 1st of August historically. So it gives you kind of one last estimate to fine tune the numbers, one last shot at a mulligan if we realize we really had butchered stuff up to that point. But there's a lot of climate signals information. July is actually a really helpful month for doing these seasonal forecasts. And normally July, thankfully, we don't have that many storms. So it does give people kind of one last shot at here's our best estimate at that point. And also with the August forecast, that first August forecast, we do issue our first 2 week forecast. So we can at least say, okay, the rest of the season, say, looks busy. The next 2 weeks, last year we said, busy season, but the next 2 weeks look fairly quiet. We expect a busy season, but not the next 2 weeks. So at least then you kind of can start to highlight, again, when you think storm activity during the season is more likely to occur.
You mentioned a few times that sometimes, if you have that time where it's a mulligan, what is that like? If you don't mind me asking, what's that like when it just, it can't be perfect. So it's a forecast.
Correct. Yeah. And so, even if you have perfect knowledge of the atmosphere ocean, you know exactly what happened during the season, you can only get about 60 to 70% of the variability in hurricane numbers. Because again, you're trying to forecast weather events on climate timescales. And so basically, in a way, we don't actually really forecast hurricanes. We actually forecast what the environment looks like. And then if you say the environment, like this year, we expect to be extremely conducive. Therefore, an environment that conducive typically yields about 11 hurricanes. So that's basically how we come up with the forecast. It's not that we're predicting, there's going to be a hurricane forming August 9th, another one, that's not what we do. But even if you have that perfect knowledge, hurricanes are weather events. So even if the entire basin is super conducive, but there's one spot where it's not, and that storm finds that one non-conducive spot, you could have it, or storms interact with each other. Storms go over land, they miss land. There's all these different things that come in that can cause basically noise in the system. So even perfect knowledge of the large scale only gives us so much. But I've certainly been a part of several pretty lousy forecasts. The most recent one that was a real stinker was 2013, where we forecast 9 hurricanes and we got 2. That's the baseball equivalent of forecasting the Chicago White Sox to have won the World Series this year. There are those now, people say, well, would that happen again? And I would say we wouldn't bust as badly. So we're always kind of tweaking our models and using newer data. Now, when we look at 2013 with the models that we currently have retrospectively, the models still don't go as low as what happened, but they are certainly more calling for maybe near to slightly below average as opposed to well above average. We think the odds of a bust this year are extremely low, just given it's mid-June and the water temperatures in the Atlantic are like we normally see in late August. So there would be some crazy stuff would have to change to make this a quiet season.
Well, Phil, thank you so much for your time. I really appreciate you being here.
Sure, no problem. Take care.
That was CSU hurricane researcher Phil Klotzbach. I'm your host, Stacey Nick, and you're listening to CSU's podcast, The Audit.